Our next unit is quadratics, so we'll be looking first at properties of quadratic functions. Now there's three different forms of a quadratic function. There's the vertex form, standard form, and factored form. We're going to be looking at today in this video the vertex form because it's very easy to visualize the parabola and also to graph it using this, and then it'll be easy to discuss the various properties. So what I have here is y equals x squared. It's kind of like our basic parabola. Now I have a table of values here for y equals x squared. So the x values are increasing by 1. And all you do remember for table of values, and if you have an equation, substitute x into the equation. So negative 3 squared is positive 9. Negative 2 squared is positive 4, and so on. And I've drawn the parabola over here. So remember, it's a U shape. It's symmetrical. Maybe not the way I've drawn it here, but it should be symmetrical. And I'm also extending it past these final points and having arrows on the top because it's not going to stop at these points of x equals 3 and x equals positive 3. It does continue on upwards forever. So what we're concerned with here are the various properties or special characteristics of the parabola. So I have a copy of the same graph on this page, and the first thing we want to look at is what is called the vertex. Now the vertex is if you follow the parabola in one direction. So I'm going from left to right. So right now I'm going down, down, down. At this point right here, the direction changes and I'm now going up. So that point right there we call the vertex, and that's where the parabola changes direction. So the vertex we give as coordinates. The x value is 0 and the y value is 0. So the graph y equals x squared will always have that vertex of 0, 0. Now something you may not have seen before, step pattern. This is how I like to place the points. Instead of having that table of values and plugging in the different x values each time, this is the pattern that the points will follow for y equals x squared. If you go one step to the side, you'll notice that the next point is one step up. If you go one step to the side again, you go up 1, 2, 3 steps up. One step to the side again, and now you're going up 1, 2, 3, 4, 5. So we call the step pattern 1, 3, 5. Those are the vertical steps. I always went 1 to the side, so x increases by 1, and then y increases by 1, and then 3, and then 5. You can probably guess that the next y value would increase by 7, and so on in that pattern. Parabolas also have a maximum or minimum value, and we only talk about the y coordinate in this case. So either the highest if it's a maximum or the lowest if it's a minimum. So looking at this parabola right here, we can see that the vertex is the lowest point that the parabola reaches. There is no maximum value because this will continue on upwards forever. So what I would say is that we have a minimum value of y equals 0. The parabola will never go below the value of y equals 0, so that is our minimum. Now the axis of symmetry, if we were to draw a vertical line that cuts the parabola in half, so that each side is a mirror image of the other. So something like that. This is called the axis of symmetry. So both sides again look exactly the same. Now we want the equation of this line. So the equation of this line is actually x equals 0, and a lot of people are confused, why is it always x equals 0? So on this line right here, if you take a look at this point, what's the x value? It's 0. If you take a look at this point up here, the y value is different, but what's the x value? It's 0. Right here, x is equal to 0. So we call the equation x equals 0 because x is always equal to 0. Now we're also going to discuss domain and range. We'll do that in class. So if you think you remember it, that's good, but we'll discuss it in class if you're a little bit confused. So we're not always going to be graphing just y equals x squared. If you remember, there are different transformations that can happen to the parabola. So looking at the equation, these numbers are different than what we saw before, and I'm going to highlight each of them in a different color. So each of these is going to change the parabola a little bit in terms of position and the shape as well. Now it's these two numbers right here which will affect the location of the vertex. So normally we would start at 0, 0 for our vertex, But this number in the bracket, so we have x plus a number, or it could be x minus a number, that's going to move the vertex to the left or to the right. Now you're going to look at that and you're going to say, okay, x plus 4 squared, that I'm going to move to the right by 4 units. But it's actually the opposite. It's a trap. If you see x plus 4 squared, it's actually a shift to the left of 4 units for the vertex. So I know that the x-coordinate of my vertex is going to be minus 4. For an explanation as to why that is, why is it the opposite, you can take a look at the summary document that I posted. Now, this last number here will move your parabola up or down. Now, this one is not confusing. It's exactly what it looks like. So plus 5 means that the parabola will go up 5, or sorry, the vertex will go up 5. So the y-coordinate will be 5. So just kind of visually here, starting at 0, 0, my vertex will go to the left 4 and then up 5. So I can draw my first point right there. Now, if you remember for the previous parabola, we had the set pattern of 1, 3, and 5. And that's the basic shape of a quadratic function. But what this number does in front of the brackets, so it's multiplying the x plus 4 squared, what's going to happen is it's going to multiply, that number is going to multiply the step pattern. So instead of the first step being positive 1, it's going to be negative 2. Instead of the second step being positive 3 or up 3, it's going to be negative 6. And negative 2 times 5, the last step will be minus 10. So what that value does, we call it the a variable in general, it's going to stretch or compress the shape, or it might reflect it as well. So we'll take a look at when I graph it. So starting at the vertex, you're always going to go to the side 1, but now I'm going down 2 steps. If I go to the side 1, I'm now going to go down 1, 2, 3, 4, 5, 6 steps. Now my last step to the side, I'd have to go down 10, but that's going to take me off my page, so I'm not going to do that right now. So now I just have to do the same thing on the other side and then draw my parabola. So 1 step to the side, down 2, 1 step to the side, down 6, and then I can draw my parabola. Now, like I said, that value of negative 2 in the equation will stretch or compress or reflect the shape. So we would say this is reflected because it's now going downwards instead of upwards. And you can notice that the steps are negative, which makes it go downwards. We also say it's stretched because these steps are longer than the original steps of 1, 3, and 5. So this one is both reflected or flipped, you can say, and stretched. Now the maximum or minimum value, because this parabola is going downwards, the vertex of negative 4 and positive 5, that's actually the highest point there will be. So what we have here is a maximum value of y equals 5. Okay, our y values will never go above 5. The axis of symmetry, so again, if I draw that line, you take a look at what your x value will always be. That is negative 4. One thing you might notice as well, that those two, the maximum value and the axis of symmetry, those numbers come from the vertex. And again, domain range we'll talk about in class.